Cthulhu fhtagn, my friends. My name is Alhazred, and I'm back again today, starting yet another YouTube series for those of you who enjoy weaving your own spells of dark magic. Some of you thought the process injection was a little bit too much for you. Admittedly, that is not a series intended for programming beginners. So, in this series, we're going to be taking a little bit of a step back and speaking directly to those among you who maybe are just starting out with their journey into the dark arts or are looking for a way to dip into programming, but maybe do something a little bit cool with it, a little bit hacky with it. That's what we're going to be doing today. We're going to be learning Python. I've specifically chosen Python because it's a very powerful language that is worthwhile for anyone in cybersecurity to know, and I would argue, really, you could do to learn Python if you're in literally any field that involves computers. It's that useful. Here are some quick reasons why you should learn Python yesterday. Number one, it's cross-platform. It'll run on Windows, Mac, Linux. The machine usually just needs to have the Python interpreter installed. And we'll talk about what that usually means in a future video. It's also relatively simple. Dynamically typed syntax. It's fantastic for automating tasks, for whipping up a quick script to do whatever you need it to do. It is absolutely awesome for that. If you watch my stream on twitch.tv, you've seen me code in Python numerous times, just off the cuff on stream, simply because it's a great language for that. Number three, it's object-oriented. This becomes useful when you're doing code reuse, which means you're going to leverage code that you've written before or somebody else has written to do something in a new script. This keeps your scripts short, simple, and that's one of the things that makes it so great at whipping up a quick script to do just about whatever you need. Another huge strength is the huge wealth of libraries that make all these complex operations in Python really simple to implement. This includes like network communications, cryptography, file system operations, threading. Normally, it's a gargantuan pain to figure out all the intricacies of these solutions and implement them down at the low levels. But Python takes care of all of that for you. For example, if you want to send HTTP requests, you don't have to write your own function to like manually create the HTTP request and start a WebSocket, or not a WebSocket, start a regular socket and send data over it and all that stuff. You don't need to worry about all of that because you can just import requests. Super easy. Python's great for that. And you know what? There's even more third-party libraries that make even more specific, even more complex operations very, very simple. A perfect example of this that you've seen many times on my stream is Impacket. Impacket is essentially a conglomeration of Python classes for you to use in your own code. It's fantastic for that. CrackMapExec imports the Impacket classes and makes great use of them. That's another humongous strength of Python right there. And lastly, it has a cool name, based on Monty Python, not the snake. True story, look it up. So, Python is one of the languages that I code in the most. And being well-versed in it is going to serve any hacker well, guaranteed. Therefore, to teach it from a bit of a hacker mindset, we're going to be coding our own malware. We'll start off very, very simply with essentially a simple reverse shell coded purely in Python, as in we're not going to be using a reverse shell one-liner like you'd see on stream that connects back to Netcat or anything like that. No, we're going to code everything in Python, and that's so that we can see all the intricacies as we build these things. And in successive videos, we're going to add to it more and more and more and more until we have a very robust and capable piece of malware. We may also do a few little offshoots, like maybe we'll code a web scraper or something of that nature. Lots of stuff we can potentially do with Python. Let me know what you want to see in the comments below. For example, for features for the malware that we could add later, I'm thinking of things like encryption, HTTP communications, credential harvesting, automated persistence, file upload and download, key logging, and like more. Let me know what you want to see down in the comment thingy below. Keep in mind, though, please, this malware is only to be used. Really, I'd ideally like you to only use it for your own learning. That's really all it's intended for. Regardless of how you use it, it's only to be used for legal and ethical purposes only. These might be the dark magics, but please use them for good. More importantly, than having, you know, a little bit of cool Python code to work with, you will hopefully understand how to begin coding your own scripts in Python and begin using it for your own purposes and starting your own projects. Take my work here and use it as a jumping off point on your own. Get your hands dirty and start coding. The earlier you start doing hands-on things, start actually programming, the faster you'll be competent in one of the most useful languages out there. Let's get started. Let's hop into the code. First, let's get a sense of our development environment. So I'm going to be using Visual Studio Code. You can use whatever IDE you want. I've used PyCharm in the past, and Atom, and even Vim and Emacs if it suits me. But I use Visual Studio Code these days for most languages. I find it very agreeable with all of its extensions and so on and so forth. You can see I've created a folder specifically for the Python Trojan project we're going to be working on today. For the two boxes we're going to be testing this on, again, we need a quote-unquote compromised machine to run the Trojan on, and we need an attack machine, an attack box that's going to be running the listener, the server of the machine. So my Windows dev box will work. It has Python installed already. Windows obviously does not have Python installed by default, but in future videos I'll show you how that doesn't really matter in some cases. But that's, again, a topic for the future. We're just going to be using the Windows box just to run the client, just to test it out. And on the server side, for our attack box, I've got my Parrot dev machine here. That's what we're going to be dealing with throughout the course of this video. Let's get started. Now, we're going to be coding two separate scripts today. One for the client and one for the server. One runs on the compromised machine, and one is going to run on our host. Okay? So let's go ahead and start with the client. We're going to code them both at the same time, more or less. But just for simplicity's sake, whenever we make changes, I'll start with the client so you don't lose track of which is which. Because they are going to kind of blend together a little bit. They're going to look a little bit similar, and I don't want you to lose track. So I make a new file called tcpclient.py. Because it's a .py file extension, my Visual Studio Code automatically knows it's Python and will apply the appropriate syntax highlighting, which is nice. So we're going to start our script as we do many Python scripts, and that's by importing the libraries we're going to need. So basically, we're going to tell Python, when Python reads an import statement, in this case, import socket, when Python reads that, the Python interpreter is going to go, okay, let me check in the Python libraries on this host and see if I have a socket library. And it's going to go looking for that, and then it's going to import all of the functions and classes and data types that we need from that library. It's going to let us make use of code that much smarter people have written. In this case, the socket library handles the underlying networking socket infrastructure, which would be a super pain in the butt otherwise. So we're thankful that there are much smarter people out there to write these libraries for us. So all we have to do is import socket, and we're ready to go. Okay, that's the only third-party library we're going to need right now. First, we're going to have to create an instance of the socket class. Okay, so we're going to do socket. From the socket library, we're going to instantiate an object of type socket. I know it's socket.socket. It's a little bit weird, but keep in mind, this is the library. This is the class in the library that we're importing, or that we're instantiating. Okay, so when we instantiate it, this Visual Studio Code did something weird here. Okay. So when we instantiate it, it takes a number of arguments. In this case, we're creating a TCP socket, so this is going to look a little bit weird. But we want socket.af inet and socket.sockstring. Now, you could do this with a UDP packet as well. I encourage you to read the documentation on python.org to see how these classes work, to read the actual documentation to see what arguments it expects. Oh, goodness. I'm all over the place today. Okay, but this instantiates an object of type socket. Now, we're going to be using this object throughout the rest of our code down here. So let's make sure that we set this object equal to a variable. Now, this variable can be anything. I'm just going to name it S for brevity's sake. But this variable, you can name this variable. I wouldn't name it socket because that would be confusing with the socket equals socket.socket. You could, but it would not be I'm not sure if the Python interpreter would even take that. I think it would. Yeah, I think it would probably take it. But it's not great code. Let's just make it an S, okay? Just make it an S. And then we want to, this is the client, right? This is going to be the Trojan. So we want it to connect out to our server. So we're going to use the connect function in the in the socket module. So, or the connect method more accurately. This is an object-oriented programming language, and here S is an object. Objects have a variety of associated functions called methods. In this case, we're going to be using the connect method. S.connect, as in we're telling the Python interpreter that this socket object has a connect method that we want to execute here. This method's going to take one argument, and that's an address object. An address object is a tuple. A tuple is a new data type we have not covered yet. It's one of 4 built-in data types in Python for like a collection of data. A data type that has multiple different pieces of data inside of it. Other ones are list, dictionary, and set, okay? But don't worry about exactly what a tuple is right now. Just know that s.connect expects a tuple, and a tuple is defined inside of parentheses. So we're going to have a double set of parentheses here. Inside the tuple, there are going to be 2 separate values. The first value is going to be an IP address. So we need to know what IP address to call out to. So let's go to our parrot, and let's do ifconfig. I've made the font quite big. 10.0.0.81 is the IP address of our parrot machine. So let's head back to Visual Studio Code, 10.0.0.81. Now, obviously, in the real world, you'd probably use a domain here, or even a variety of domains to possibly connect back to for fallback. The possibilities here are endless, but for simplicity's sake, we're just going to be using an IP address here. And then we need the port to connect back on. And so the port we're going to be using is obviously that nicest of all ports, 6969. Okay? It doesn't really matter what port you choose as long as it's not in use. So it's up to you what you want to use as long as it's not going to be in use on the server, which it shouldn't be. There's a lot of considerations you can use here, but for right now, we'll just, for simplicity's sake, we'll use 6969. Okay? That's all the client is going to do at this point. Let's go ahead and put a pause on the client now, and let's make the server. So we'll make another file called tcpserver.py. Okay? So we come over here to TCP server, and we're going to make the other side of this communication, of the TCP communication, the netcat listener, if you will. This is the role netcat often fills in our reverse shell one-liners, that is. The first thing we're going to need is, again, we're going to need the socket library. Import socket. Excellent. So the next, we're going to, just like before, we're going to need to create a socket object. Socket.socket. And then socket.af, socket.sock stream. Okay? All right. So remember, this is the one that's doing the connecting. The connection is going from client to server here, right? We want the server to listen. We need to do a couple of things in sequence here. First, we need to bind to a port. We need to bind to that port that we decided. So we're going to do s.bind. We're going to execute the bind method, okay, of the socket object. Socket objects have a variety of methods they can execute. And just like the connect object, this also takes a tuple, okay? Again, don't worry about exactly what tuples are right now. Just trust me. But I encourage you to research on your own. But just trust me that a tuple is what is appropriate here, okay? And that's why you have this double set of parentheses, okay? You'll get an error if you do it with just single parentheses. And we'll do port 6969, because remember, the client is calling back to us on 6969. But that port is arbitrary and nice, so keep that in mind. You can make that port whatever you want. And now we're going to listen on that port. We're going to execute the listen method. This is basically just going to allow the server to accept connections. It's not actually going to accept anything. It's just going to enable connections to come in. If we actually want to accept something, we need to do an s.accept now. S.accept. So now the socket is going to wait for a connection. This accept method is going to return some values for us, specifically 2 values. We want to use those values. Let's just set them equal to variables. We'll call those variables con and addr, but again, these are arbitrary names. It's good to name your variables something that reminds you what they are and what they do. The accept method is going to return a connection object, as in a socket object that we can interact with to send data across the socket, and it's going to return an address object. Basically, it's going to return a tuple, just like this one, that indicates what IP address we've connected to and what port they've connected from. Okay, so that's what this is going to do. And just for debugging purposes, this is very useful in Python. We're going to use a print statement. It's not a statement. The print function in Python 3. I'm still saying as if Python 2 continues to plague me. The print function here is going to just print stuff to the screen. A lot of times when you're debugging your code in Python, you don't really need a fancy debugger or anything. Just put some print statements in the code. I mean, that gets the job done for me more often than not, in my opinion. We're just going to have it print out the connection object. And this is how you concatenate strings with a plus sign. We have a string object here. Everything in Python is an object. So try and think in terms of objects when you're coding in Python. And we're going to just concatenate this con object to this string here. Okay. And we're going to print address. And we're just going to make sure that the connection is working correctly, right? We're going to use Control S to save both of these. All right. And we're going to go to our development machines. We'll go to parrot first. So Python 3 TCP server.py. And we see that it is listening. The script is listening for a connection. So let's go over to our fake compromised machine here. And we can do Python 3. Or it's just Python on this side, excuse me. TCP client.py. Okay, so it terminated immediately, and that's to be expected because we didn't put anything else to do with the socket. The script is terminated now. Once it makes a connection, the script reaches its end, and the interpreter closes up gracefully. No problems there. But let's go back over here, and we get some weird output, right? We get a traceback. So this is what a Python error looks like. Python honestly has one of the most helpful errors I've seen. I usually can figure out what the problem is in Python code when I have an error. In this case, you want to usually look at the last line of the error to see exactly what's going on. And we see that the Python interpreter is complaining that we can only concatenate a string to a string. In this case, it's showing that the error is in this particular line right here, where we try to concatenate this con object with this string connection. And Python is saying, this is not a string. I can't do that. No problem, right? No problem. We can go back over to Visual Studio Code. We can fix that right off the bat. Okay? So kind of the quick and dirty way of fixing this that I do not recommend is just to cast it to a string. Okay? And we can do it down here as well. Even though this didn't generate an error, what's important to remember is that the Python interpreter reads line by line. It's not going to read the whole thing and check for errors before it executes it. It immediately starts executing on the first line. If it hits an error, you're going to get a traceback, and it's going to stop execution right there, right? So I think I put too many parentheses. There we go. Okay. Visual Studio Code was helping me out there by putting a little squiggly line under, meaning I had like some kind of a problem with my line there. This is kind of a quick and dirty way, just basically saying to Python, look, I don't care if it's a different object. Just print it, you idiot. This is kind of, kind of sloppy. I wouldn't leave this in my normal code, but it's fine for debugging purposes, okay? I'm just doing this to demonstrate to you a little bit of Python-based debugging. So we can hit up arrow and just start the server there. We can come back over here. We can execute it. All right, no problems, right? We come back over here, and now we don't get a traceback. We don't get an error. We see that Python doing the best job it can of converting this socket object into a string and has printed it out for us. And then down here in the address, we see that it's printed out another tuple, which is the IP address of my Windows machine, 10.0.0.26, and the port it's connecting from. This port will be different every time. It's randomly selected. There needs to be a port on both sides. We're normally only concerned with the port we're connecting to. The port you're connecting from is usually just a random high port. This will be different for you. Don't worry about it. We're not going to do anything with it. Okay? So we verified that the connection is working properly. Okay? We can connect. All of that is working just fine. So now we want to actually do something with the connection, right? We want to actually send data back and forth. okay? Let's verify that we can make a connection, but now let's send data back and forth, right? So we're going to send commands, right? So we can call this variable command. We can tell the Python script to, hey, you're going to be receiving something on that socket. So we're going to do s.receive. We're going to tell Python, hey, execute the receive method of the socket object, and that's going to make Python wait for some data to be sent over the socket, okay? This argument at once here is just a number of bytes that is the maximum the socket will allow. In this case, it helps if it's a power of 2, so I'll do 4096, because I can't imagine we're going to be sending anything that is more than 4,000 characters. Just as long as it's large enough for you, it doesn't really matter. And we have to do one more little thing here. We need to do .decode UTF-8. And the reason we need to do this is because the data that's received over this socket is going to be binary. It's going to be a bytes object to Python. Python doesn't know how to interpret binary until you tell it how. So we're going to have Python decode that as UTF-8. That's just a type of encoding. It's also the default, so you can just leave this out. You can just leave this UTF-8 out and it'll work the exact same way. I'm going to include the UTF-8 just for clarity's sake, but there are lots of other encodings that you can use as well, but I'm just going to use UTF-8 for simplicity's sake. It'll display the best in the terminal because most terminals are UTF-8 by default. All right, so we need to turn the binary into something that will display well in the terminal because a Python bytes object is not going to display well in the terminal a lot of times. For right now, let's just do a print statement. Command received. Command. Okay? Obviously, we're not going to execute the command just yet. I'll show you that in a little bit. We're taking this in stages, a little bit at a time. This is how you want to code your Python scripts. You do a little bit of functionality, you test that functionality, and you make sure it works as you're expecting, then you add a little bit more functionality. It's not really great to just do your whole script and then see if it runs because you never know what might... I find that this is much more consistent, will help you get stuff done much more efficiently. Okay? So we don't really need these anymore. So let's go ahead and comment them out in case we need them in the future. The Python comment is a pound symbol. Basically, that's just telling the Python interpreter, hey, don't execute this line. Okay? Don't execute this line, and VS Code will make it green to indicate it's not being executed. But we can change this, and we can say connection received from... We're going to take this tuple. Keep in mind that this was a tuple. Let's look again at this. What was being returned here is a tuple, so it is one of those collections of data objects that we were talking about. We see that the first element in this tuple is an IP address, and the second is the port it's connecting from. We don't really care about this, but this can be helpful. This tells us where our shell is connecting from, our Trojan is connecting from, which can be useful to us. So let's go ahead and just say, hey, ADDR 0. So if you want to display just one element from a array-like object, like a tuple or a set or a dictionary or whatever, the way that you subscript it is by using these brackets here, these angle brackets. Arrays in Python start at 0 as the good Lord intended. So if we want to get the first element in this object, we would use the number 0. So this should print the IP address of our Windows machine, our compromised Windows machine, to the screen, just to let us know that we've received a connection. The next thing we can do is we can accept a command from the command line. We want to like open up like a pseudo interactive prompt here so that we can enter multiple commands. Okay, so we're going to do command equals, and if you want to get input from the command line, you use the input function. Basically, what this is going to do is it's just going to make Python wait for the user to type something into the terminal and press enter. And once that enter key press is received, the resulting input will be stored in the command variable. So this is how you get input from a user. There is an optional argument for the input function, and that's just the prompt you want to use. So you can use anything here. I'll just use CMD with a little greater than symbol there, just to look a little bit nicer. We're going to send the command. Okay, we want to send the command. So con.send, because remember, after we accept a connection, we're going to be interacting with this socket object we received with this con socket object. Okay, so we're going to use con.send command. And keep in mind, this is going to be just a string, and we need it to be bytes. We need it to be bytes. We will get an error if we try to do it just as is here. We need to encode it, and we're going to be encoding it from UTF-8. We're going to have Python say, hey, this is a UTF-8 string that we're putting in on the terminal. I need you to turn it into bytes with the encode function, and then send it over. Okay? Pretty simple stuff. Hopefully that makes sense. Let's go ahead and save it. Always make sure to save your work. I frequently forget to save, so I often spam Control-S very, very often. So let's go ahead and start the server again. Let's execute the client. And we notice it doesn't terminate immediately now. Now it's waiting for a command, right? It's waiting for a command that we're going to send it. So let's go back over here. And we see we have our CMD prompt here. And then we can send, who am I? And then it terminates because I forgot to have it send stuff back. But if we look over here, we see command received. So we see that the TCP client has received our command. We can send data over our connection, right? Okay, great. So let's open back up our VS Code. Let's go back to the client. Again, we're starting on the client every time just to be safe, or just so that I don't lose you. Whenever we come back to the code, we'll be starting with the client. The two are going to look a little bit similar, so just try and keep track of which is the client and which is the server, okay? So we don't really need to send that anymore. So now let's actually execute a command, right? If we're going to execute a command, we need another library. Now, you're always free to implement this functionality on your own, but that would be a lot of code, and it's not really for a beginner. So let's just use another library here. Import subprocess. Many of you will have seen me using the OS module to execute commands on stream, os.system. The OS module has a system method that is useful. A system function that is useful for executing operating system commands. That's not useful to us here because the system module cannot return the command output. Okay, we want to return command output. The subprocess module is ideal for that. So we're going to be using the run function in the subprocess module. So once we have the command, we receive the command over the connection. We're going to be running subprocess, that's the name of the module, the run function in the subprocess module. Now, this takes a large number of arguments as Visual Studio Code is trying to be helpful here. Don't be confused by this. This is a complicated function with a lot of possible things you can put into it. I encourage you, again, to go to python.org and read the documentation. I'll link it below. Just to make it even easier for you. But we only need a couple of these arguments. So the first argument it wants is the actual command to run. So we're just going to feed it the string that we received from the socket and then decode it. And then we want to set shell equals true. Why do we do this? We do this because we want to run it in a command shell. If you do this, if you leave this off, by default it is false. And you'll still be able to execute the command with the arguments that you give it, but you won't have the benefit of like pipes, output redirectors, environment variables, shortcuts, things like that. Let's just execute it in a command shell so we have all those more powerful features. Now we need to deal with the output, right? We want to get the command output. If we want the command output, we have to set stdout equals subprocess.pipe. That means we're going to open a pipe to the output so that we can retrieve it. And we're also going to set stderr equals subprocess.stdout. That just means, hey, if you have standard error, just redirect it to standard out, and standard out is going to a pipe. So we'll get standard out and standard error, okay? And we'll show that here in a little bit. And then we're going to send the output. We're just going to send the output over the pipe. s.send cmd.stdout. There we go. I forgot to set a variable. We want to set the output of this function to a variable, and then we're going to access the stdout attribute. This is going to include a number of things. This is a completed process object and it has a number of attributes. We just want the stdout attribute because we're redirecting stderr to stdout as well. So we'll also get that. We're gonna run a command and we're gonna send the output. Okay, very simple. Let's go back over to the server. We do need to receive the output of our command, right? So we want to print it to the screen so that we can see it. Con.receive. So we're going to receive, we can put 4096 here. Remember, this is just the size, the maximum size that it's going to retrieve. And we're going to decode it to UTF-8 again. We're going to receive bytes. Every time we get something over a socket, it's going to be bytes. We have to decode it into a string so we can print it out. We're going to send our command, then we're going to receive the output of the command, and we're going to print it to the screen. Pretty straightforward stuff. Let's go ahead and execute the server. Execute the client. Cool. So no errors yet, which is great. We get our CMD. Let's do who am I. We get the output of the who am I command, which is the host name and then a backslash and then the username of the user. And then it just terminates immediately because, again, all we're having it do is send and receive one command, and then that's the end of the script, so it stops. And you'll see that this one also terminated over here. Now, we just need to do really just one more thing here. We want to send multiple commands, right? We want the script to run indefinitely and receive an indefinite number of commands. So now we need some way of keeping the script running, keeping the socket open, so that we can send and receive multiple commands. And we're going to do that using what's called a loop. We're going to be using our first programming logic here by implementing a loop. A loop, basically in programming, tells the program to execute a certain block of code a certain number of times, okay? Either a fixed number of times or until some condition is satisfied or something of that nature. The most appropriate loop we can use here is called a while loop. The while loop is going to constantly test to see if a certain condition is true or false, and as long as it's true, it will execute all of the code in that code block. So you could put any condition here. You can put while a equals 1 or something, but a is not defined or anything like that. The easiest way is just to go 1 equals 1, or you can just do while equal true, okay? While true. While true is going to effectively just make the while loop execute indefinitely, because true is never going to not be true, right? The true with a capital T in Python is the constant value that refers to a true Boolean value. So this is never going to be false. So the while loop is basically going to execute forever until we tell it to stop. And we need to indent this code block. Python delineates code blocks with indentation. So in Visual Studio, I can just highlight all these and indent it. But all the lines you want to be in the while loop need to be indented under the while loop. Okay, and there needs to be this colon here indicating that a code block is going to follow. The first thing it's going to do after it executes this, it's going to go to while, and it's going to say, hey, is true true? Which obviously it's always going to be true, right? Then we're going to enter the code block. If true was not true, this code block would not get executed even one time. The script would just terminate there. But since true is true, it's going to go into the code block. It's going to receive a command. It's going to run the command, and it's going to send the output. And then it's going to go loop back around. It's going to say, hey, is true equal to true? Yep, still true. Then it's going to go back through the loop again. And it's going to keep doing that until it's forcibly terminated. We've given it no way to gracefully terminate. So it's just going to keep running basically indefinitely for as long as the machine is booted, that is, or the process doesn't error out or something like that. So we kind of want to do something similar over here, right, on the server side. Let's do, after we receive that connection, we'll do another while true, and we'll just indent all of this. Perfect. So now, indefinitely, the server is going to receive a command from the command line. It's going to send that command, and it's going to print the output that it receives from the client. Then it's going to loop back around. It's going to do all that over again. And it's going to keep doing that over and over again. Okay? Because we haven't given it away to a condition to terminate. So let's verify that that works. We saved them both. Let's go ahead and run our server. Go ahead and run the client. Let's go back over to the server side. Let's execute a whoami command. And we see we get a command, and then we start the loop over again. So now we can execute a different command, dir. We can just execute some garbage. And then we see we get the proper error message because, remember, in the run function, we specified that std error should be sent to std out. So we are able to get standard out here, or standard error, excuse me. And we can do this forever. You can execute as many commands as you want, and it'll keep executing them. All right? But now we have a bit of a problem. If we want to terminate our shell, we do exit, and we see that the script does not terminate. That's because we haven't given it a way to gracefully terminate, really. So we need to sort of Control-C and just kill it, which is kind of sloppy. And then if we look over at the Windows machine, we see that the client, it's still waiting for commands to come that will never come. It also has not been given a way to terminate. So we just need to kill that. Okay? So now we're going to do one more thing. The last thing we're going to do is just give it a way to terminate. Okay? And the way we're going to do that is we're going to use another bit, another programming logic gate, if you will. And we're going to use what's called an if statement. An if statement is how you tell a program, hey, if a certain condition is true, I want you to execute this code block. And if it's not true, I want you to do something else. Okay? In this case, we're going to test if... Oh, I'm sorry. We want to start with the client. My mistake. I'm sorry. I said we're starting with the client this whole time. Okay? So we're going to receive a command, and then we're going to say if command equals exit. So this is basically saying, hey, if this variable we just received is exactly equal to these 4 letters, as in the data you received from the server was EXIT in order, then do this. And the thing we're going to do is close the socket, s.close. That'll gracefully close the socket for us. And then we're just going to break out of the loop. Okay? The break statement will forcibly break out of this while loop, and then the script will just terminate because there is no more code beyond that. So break will effectively terminate the script. It'll terminate this loop, which terminates the script because the loop is the last thing in the script. Now, some of you may like to put an else statement here. If and else are kind of brothers, brother and sister, I suppose. Basically, you would include an else statement. If this statement is true, then do this. Otherwise, do whatever's in the else statement. Some of you may choose to do this. This is perfectly valid code. This is perfectly fine to do. You don't actually need to do this, though. Don't need to put that else there. I'm going to leave it off for simplicity's sake, because less words in code, in my opinion, is better than more words in code. But some programmers may prefer that else there just for readability's sake. It may help them. In this case, we're only going to be executing this break statement if exit is sent, in which case we're going to be breaking out of the loop and this won't execute anyways. So we don't really care that there's an else statement here or not, because this code is only going to execute if exit is not sent. So that else is not necessary, but you can sure put it there if you want it, if you would like it to. So we'll go back over to the server, and we're going to do something very, very similar on the server side. Once we receive the command, we're going to do if command equals exit, colon. And then we're going to do, remember, we have to tell the client to exit as well. So we're going to have it send exit. Remember, we have to encode it to make sure the socket is getting a bytes object, which is what it wants. And then we're going to close the socket. So con.close, and then we're going to break. So this'll force the server to terminate gracefully. And similar to before, you can either put that else statement or not put it there. It doesn't really matter. If this if statement executes, we're not going to hit these lines of code because we're going to be breaking out of the loop. So now we can try and execute this. Hopefully this will be the last time we have to do this. So let's go ahead and execute the server. Let's execute the client. No errors yet. That's a good sign. Who am I? Dir. Who am I? /priv set to get all the environment variables. You can execute commands forever. And then if we want to terminate it, we just go exit. And we see that this time the script terminates gracefully without the need to Control-C it. And if we come back over here, we see that the script has also terminated over here as well. Great. So that's a very simple Trojan client and server that we're going to be building off in future iterations in this series. So stay tuned for that. But put in the comments what you'd like to see it do, because Python's very powerful. We can make it do a lot of stuff. Again, to be used ethically and for research purposes. So yeah, I hope you guys enjoyed that. So that's all I have for you for today, my friends. This code is in a GitHub repo linked below in the description. If you want to pull it down and play with it on your own, which I deeply recommend, let me know in the comments below what you'd like to see me add to this code in future videos. But for right now, take it, pull it down, play with it, experiment with it, add your own bits. That's how you get started programming. Take what I've given you and make it better, improve it, give it more functionality, as we will do in future videos. I hope you enjoyed this brief foray into hacking with Python. Stay safe, and I'll see you again in the next video. Thanks for watching.